I'm presenting my screen. Just let me know whether it is visible or not. Is it visible?
Yes, ma'am.
Okay. So this is the rough block diagram of a computer. Okay, data is given to a computer to process via input devices. Then within the computer, there are some units, some circuitry which process the data, and you will get output in the some form of information you'll get as your output device is there. If you connected printer, if you connect to speakers or headphones or any other devices, accordingly you will receive the output from the computer. Now, input and output devices we have already covered. So today we'll discuss data processing unit, how the data is processed within the computer. Now, the main unit which process the data is called CPU, Central Processing Unit. Now, this CPU contains control unit, arithmetic and logic unit, which is ALU, and memory. So there are three broader circuitry: control, ALU, and memory. Now, control unit basically controls both input, output, arithmetic logic unit, memory. It controls each and every section of a computer. So that's why it is called control unit. Arithmetic and logic unit, there are various operations, arithmetic operations. Arithmetic operation, it covers all the mathematical uh, calculations such as addition, subtraction, division, multiplication. So that type of uh, function can be done by arithmetic unit, and logic unit performs the comparison part, logic part, whether it add or if there is instruction or A or B, and like A and B. So that type of logic comparison, whether it is right or wrong, yes or no. So all logic analysis is done in logical unit. And then memory. Memory stores the data temporarily and permanently. There are two types of storage devices within a computer that we call memory devices, storage devices. So we'll see one by one. Here in Hindi, it is only written the same thing which I have explained to you. Here ALU means arithmetic operations like addition, subtraction, division, multiplication, and logical units. Yes, no, comparison and all. Control unit controls all the processes, all the phenomena which is going on within the computer, including your the way you connect to the computer through some instructions. They process it and then they produce the output in your output devices. Result can be seen at the output devices, and it controls each and every unit, what is going on, how it is going on, what instructions to be needed to process the data. So it manages all the operations. That's why it is called the manager of the computer, control unit. Okay, then memory unit, it's a storage device. It just follow or store all the commands, all the processes, all the instructions to which are needed to process a particular input which you are giving to the computer. And they are of two types, which we'll see later. So here are the main memory devices. So there are broadly the memory of the computer is divided into two parts, internal memory and external memory. Now what is internal memory? Internal memory generally within the computer, within the CPU, it's a part of CPU. That's why it is called internal memory, which is primary memory. Now this primary memory is of two types, RAM and ROM. RAM is random access memory, or you can say read write memory, and ROM is read only memory. Now this RAM is again of two types, static RAM and dynamic RAM, SRAM and DRAM. And ROM is of three types, PROM. PROM means programmable ROM. Then EPROM. EPROM is erasable programmable ROM. And then EEPROM. EEPROM means electrically erasable programming ROM. And there are magnetic storage, optical storage, and flash storage. All these three types are coming under the heading secondary memory, which is the external memory. External memory means it is external to the CPU. It is not a part. So depending upon how the storing is done, the storage phenomena is done. If it is of magnetic coating, magnetic material is used in a particular device, then it is magnetic storage. The types of magnetic storage are HDD, floppy disk, and magnetic tape. And optical storage, if it is done optically using some laser, some optical beam, then it is such devices are under optical storage, which is CD and DVD. And flash storage, some external card, external device that is pen drive or memory card, it both comes under flash storage. So one by one we'll see. First we'll see primary memory. Primary memory, RAM and ROM. RAM is SRAM and DRAM. ROM is PROM, EPROM, and EEPROM. So primary memory is generally called the main memory. Sometimes they ask in the examination what is the main memory of a computer. So primary memories are considered as main memory because they store the data and program for the processing purpose at present. So presently, whatever is going on under the computer, when you start a computer, when you run a program, when you give instruction to them, accordingly the processing is done. So all the instructions are stored in main memory that works for you. So primary memories are of two types, but one more memory, which is the cache memory, is also considered as a part of primary memory. The storage capacity of primary memories is less, very, very less, as compared to secondary memories. But they process the data very fast. They are fast, but having the less storage. They may be volatile, they may be non-volatile. Volatile means the instructions which are stored in that particular memory, they remain in that memory only till the computer is working. If you close your computer, if shut down your computer, then all the instructions stored are just vanish off. So that's why they are called volatile memories. Non-volatile memories, they store permanently data, whether the computer is running your program or it is not working. Now, because volatile memories are just placed near your CPU, so they are very much fast. As soon as you open up your computer and run a program, all the instructions which is needed to run those programs are stored in that memory. That is the primary memory. So primary memory, that's why they are called internal memory. Primary storage or primary memory or internal memory are all the names of the same memory. Now, first primary memory is RAM, random access memory. Just 1 second. So this is the random access memory, or the RAM is the main memory of a computer, where the file is loaded or instructions are loaded as soon as you open your computer, because they are having the instructions to run the computer, and they also get the instructions from other memory, whatever is needed, as you put your instructions or your input to process a particular task. So whatever is going on in your computer when you are running, you are working in a computer, that means all the functions, all the instructions are there in the RAM. So they are running in the RAM, random access memory. And when you shut down your computer, when you close your work, then all the instructions will be just vanish off. That's why it is temporary storage, and it is called volatile memory. Now we'll see SRAM and DRAM. S stands for static random access memory, and dynamic access random access memory. Now this random access memory, which is static, SRAM, this is the main memory. Random access memory is main, and in that random access memory, SRAM is main memory. And DRAM, which is the dynamic random access memory, this can be used as a cache memory just near to CPU. So all the instructions which CPU needs to process your instructions, the cache memory provides all those instructions from the permanent storage devices, permanent storage memory. Now, to store this instructions of SRAM, we need transistors. So transistors are used in SRAM, and capacitors are used in DRAM to store the data. In SRAM, you don't need to refresh your data, but in DRAM, if the data is stored for a long time, you have to refresh it again and again. Now, SRAM, the capacity of SRAM is very less as compared to DRAM. DRAM storage capacity is somewhat greater, somewhat larger. Now, this SRAM is fast memory, and as compared to SRAM, this DRAM is a slower memory. Now, SRAM is very costly as compared to DRAM. Now, the next memory is ROM, which is read-only memory. Read-only memory means you can only read the instructions, read the program, but you cannot add, or you cannot, manipulate the data which is stored in ROM. But here in RAM, that's why it is called read-write memory. You can read the instructions, you can write. If some modification you want to do, you have to make, you can make. And but here in ROM, only you can read the data, you can read the instructions, you cannot be, you are not having the authority to change the instructions, whatever it is having. So some fixed program which are required to, run the computer to process the instructions, they are already fixed. They are stored within the memory chip. So that type of memory device or storage device is read-only memory or ROM. Like firmware. Firmware, every computer is having in ROM, which is responsible to start the computer. So just remember this software, which is known as firmware, which is responsible to start the program, to run the program when you just open your computer. Now, this is non-volatile. Non-volatile means the storage is permanent, whether the computer is working or it is not working. If it is switched off, then also it is there in the permanent storage. But the capacity is less. Now, ROM is slower memory as compared to RAM. All right. And it is comparatively cheaper. So, RAM is costly, RAM is faster, ROM is slower and somewhat cheaper as compared to RAM. Now, ROM is of three types: PROM, EPROM, and EEPROM. Now, let's see something about these three. So, PROM is programmable read only memory, EPROM is erasable programmable read only memory, EEPROM is electrically erasable programmable read only memory. You have to remember their names and what does this abbreviated form PROM, EPROM, EEPROM stands for, and how the programming is done. Like in PROM, this is one time programmable chip and it is cheaper as compared to ROM, and it is the oldest form, and it covers by a plastic cover. It is covered by a plastic. Now, EPROM is erasable programmable. Means you can erase if you want with the help of ultraviolet rays. Some processing has to be required. You can't just write a program and then it is reprogrammed in ROM. Not, it is not possible. Another type of memory, it is EPROM, erasable programmable, but this erasing function has been done by using ultraviolet rays. All right, and they are costly as compared to PROM. It is the advanced version because you can you can reprogram them, but the function and the process is somewhat typical. Ultraviolet rays are used to reprogramming, and it is covered by quartz window. And EEPROM is electrically erasable programmable read-only memory. Electrical, through the use of this electrical charge, they are reprogrammed, and they are the costliest ROM. And this is the latest version, and it is covered by a transparent plastic box. Now, cache memory is again a small memory which stores the data and instructions so that whenever the processing unit, CPU needs, this cache memory make it available to the CPU. And this is also a temporary memory, temporary storage, and but the speed is very fast. This is very fast memory, and this is in between CPU and RAM. Earlier we have had this discussion that this cache memory is a form of DRAM, dynamic RAM, and it is in between CPU and RAM, so that whatever instructions a processing unit need, just it provides from the RAM to the CPU. Cache memory is doing that function. So if this cache memory is very fast, then the functioning of a computer gets enhanced. It becomes more faster, and your like the input, processing and output, the time required to process a data becomes very, very less. So functioning of this cache memory makes a computer very fast and useful also in some of the areas. Now, secondary memories are the permanent storage devices, and they can store large amount of data, software programs, and their speed, their capacity. Speed is not faster, but their storage capacity will be in terabytes nowadays. Just opposite to primary memories, where the maximum storage will be up to some gigabytes, not bits, bytes. 32 bytes storage till this book has been written. So whatever file or application or multimedia, audio, video, or graphics, images, whatever you store, all those things are stored in secondary storage devices, secondary memory. And whatever you have stored, you can't access it directly. First you have to start a computer, then the data will be in your primary memory, it is loaded in there, and then you can see those whatever you have stored, you can see that. So the secondary memories are very, very slower as compared to RAM. Now, what are those secondary memories? So they are HDD, which is the hard disk drive, CD, DVD, compact disc, digital video disc, SD card, pen drives, Blu-ray disc, floppy disk. Earlier days, floppy disk, CD, DVD, they are used. Magnetic tapes were used. SDD nowadays, SDD and HDDs we are using at present. Now, one more thing, the stored, the instructions or programs which are stored in secondary memories will be safe whether the computer is working or not working. They are presented in front of you whenever you want to. So, HDD and SDD, these all secondary devices, pen drives or CD or DVDs, whatever, they are just like a backup memory. You can use it like a backup memory. So whatever you want to store some programs for future use, you can store in that memories because their capacity is larger and they are comparatively cheaper.
Ma'am, SDD is SSD, sorry, SSD. Is that a flash storage device?
Yes, it is storage device.
In storage also, there are three kinds, right, ma'am? Is that a flash storage device?
Flash storage, you are saying?
Yeah. Is what kind of
No, pen drive and what?
memory card are there?
Ah,
SDD,
and HDD.
SDD. Sorry, SSD.
Yes, yes, yes. See here.
SD card, ma'am. Yeah, SD
Memory
card.
card, pen
Is
drive.
that a flash storage device?
Flash memory, you can say it.
Yeah.
Memory.
Okay. Okay.
Now, secondary memories are of three types. We are discussing it right now. Magnetic storage, optical, and flash, depending upon on what type, how you are storing the devices. In magnetic tape devices, they are having this is seen here. This is a disk, a very thick disk of a magnetic material, and then magnetically this data is stored one by one, and it is accessed sequentially also, like your audio cassettes. All right, so you can't play randomly. If you want to play, you want to go like in between whatever is stored. You want to, access directly. So you can't access, or you can't jump to that. You have to go sequentially, starting to till end. So it runs like that only. Now, magnetic disk, it is seen here. This is the magnetic disk, which is made of metal and metal plate. And then a magnetic material coating is done over it. And this magnetic reader is this one. This is the mechanical arm which just move over, and you will get whatever is written on that disk. This is also, you can write it and you can read it both. You can change the data also here. Then hard disk drive. Hard disk drive is also a memory device which is used the instructions of operating systems, computer applications, your data file also you can store for a longer time. So this is again a permanent storage device. Then floppy disk. It is a removable device, like it is not within your computer, but you can insert it, see the program, store the data, and you can remove it like that. So it is a removable magnetic disk. This is also a type of magnetic disk. In 90s, this they are used, but their storage capacity is not very much, because as the inventions goes on, there are various other drives came in, optical devices, hard disks, which are having much more capacity, much more easier to handle, and capacity is also very, very large as compared to this floppy disk. So they are used. This is a simple 3.5-inch disk, which stores 1.4 megabit byte data only. Now, optical disk, where this optics or light rays are used to store, to erase the program, to write the program, to read the program. So this is again a secondary storage devices, because it is not a part of your computer. It is a removable device again. So this disk, you can store music, you can store video or any software program or some presentations and all. And laser beam is used, high frequency beams, and their storage capacity is again more than which we earlier discussed, floppy disk. Now you must have used such types of compact disc, and then DVDs, digital versatile disc, Blu-ray disc also. So all those discs they are made of plastic, and optically the program has been written over it using the laser beam, audio, video, or any text or presentation. So maximum capacity of a CD is 700 MB, 700 megabytes you can store. Digital versatile disk is also known as digital video disk. So sometimes they ask, what does this DVD mean, CD means? So you must know there are two names, versatile disk or video disk. Their capacity is somewhat larger because they are used to store videos, generally movies and all. All video, audio you can store at one place. Their capacity will be 4.7 to 8.5 gigabytes. Like HD type, high definition type videos and movies you can store in DVDs. Now, Blu-ray disc, again, it is an optical device, and the size of this disc is same as CD or DVD, but the storage capacity is multiple times as compared to CD and DVD because it can store 25 gigabyte. And the main use is to store high definition movies or video because the quality gets improved multiple times. And sometimes to read the data, the blue laser is used. That's why it is called Blu-ray disc. It's a particular frequency of a light, so that is used. Now, flash memory, again, it is a secondary storage devices which are external to your computer, CPU, or the main motherboard. The main, again, its use is to store the data, to back up the functioning of your computer. So, like any other memory devices, they data is electrically stored and it can be removed or rewrite. You can rewrite your data or instructions electrically. Generally, they are removable storage devices. You can transfer your data from one computer to another computer by using such type of devices. First, you store your data to these devices and then transfer it to the other device, other computer. Now, few examples are memory card. So it's a simple chip which is used in phone also to increase the storage capacity of your mobile phone or your digital camera or your MP3 player or some other devices. So such cards you can add additional memory card to the particular uh, thing, whichever you are using, whether it is a computer, phone, or camera, or any other portable device to store the data, large amount of data. Now, pen drives, they are again a portable storage device. Again, it can store your audio file, video file, or any text file or images and all. And this can be inserted to a computer using a USB port. Then SSD cards are also there. SSD is solid state drive, which is again, this is a new generation data storage device because most of the computers are having this type of device nowadays. This is very fast as compared to HDD, but the size is less and cost is very, very high, very, very expensive devices, SSD cards. We'll see questions afterwards. First, we complete this. Now, the unit of how to measure the memory of a particular storage device. So they are used, the unit which is used is bytes. Now, what is byte? Byte is combination of 8 bits. So actually, we learned that computer is working on 2 digits, 0 or 1, right? So what is they call binary digits. Now, if some character or some instruction is represented by 4 bits, then it is called one nibble. So one nibble contains 4 bits, a combination of 4 bits, 4 combination zeros and 1, combination of zeros and 1 4 times. 0 0 0 1 1 0 0 1, like that. So 4 bits, 1 nibble, and if the instructions are in 8 bits, because if you only give instructions in 0 and 1, and then it will be very difficult to increase the capacity. So 8 bits is equal to 1 byte. This is the unit for the measurement of storage of a memory. So that's why, what is 1 byte? 1 byte is a combination of 8 bits. What is nibble? It is a combination of 4 bits. What is binary? It is combination of 2 bits, 0 and 1. This is again 4-bit means 0 and 1, but the combination will be 4 bits are there, 0 1 1 0, like that. And in 8 bits there are 8 series. 8 bits are there in 1 byte. And again, there is 1 kilobyte. 1 kilobyte means, kilo means 1000 generally in decimal. But in binary, it comes 1024 bytes. Right? And again, if you increase it by 1000 times, or again, it will be increased by 1K more, then it will be 1 MB, 1 megabyte. If you again increase it by 1000 times, that means again it will be 1 gigabyte, then 1 terabyte, then 1 petabyte, 1 exabyte, then 1 zettabyte. So again it is 1 yoto, and the largest one is geop. Geop is the highest memory measurement unit. And how to remember? It is given code word here, BNBK NGT road, pizza khane gaya. It's something it is written. So BN means what? Bit, nibble, byte, kilo, then M stands for mega, giga, tera, P is peta, exa, zeta, yoto, and then Bronto and Geop is left here. But here Gaya you can no, it is not there. So Bronto and Geop is again above Yoto bytes. So just remember this table. Sometimes they ask how many bytes are there in 1024 terabytes, whether it is 1 petabyte, 1 terabyte, or 1 hexa, or 1 zeta. So 1024 terabyte is equal to 1 petabyte. So that way you can learn this table. This is the thing which you should remember. BNBK MGT pizza. MGT road पे पिज्जा खाने गया. Now this is the hierarchy of a storage devices. If you learn, then you can understand many things together in a single frame. Now here, this bar is from up to down. It is increasing downwards. And here, the cost and speed is increasing from bottom to top. So this is increase in capacity and transfer time. Means this CPU and register, they are having least capacity and least time, means they are faster. But their cost and their speed is very, very high. All right. So such this type you can read. Cache memory, again, they are having less storage capacity, lesser time as compared to register. So like that, this magnetic tape and CD-ROM, this is having the maximum capacity and maximum transfer time. And also their cost and their speed is very, very less. But the CPU and register, they are the costliest and their speed is very, very fast. So this is the hierarchy. Here you can see this is the central processing unit, your CPU, which is, and this is huge potentially size wise, and they are least expensive as compared to other devices. They are least expensive, but they are very slow because their speed is in seconds. So this is used offline storage like tape drives and etc. Second one is this hard disk, which is slower, as not very slow. It is somewhat faster than this device. This hard disk is somewhat faster, but it is less speed as compared to RAM and other registers. And it is large, but not that size is somewhat lesser as compared to the lower device. And it is having price, but not much. Then there is a RAM. RAM is faster as compared to this hard disk, having the speed 100 nanoseconds. Milliseconds means 10 raised to minus 3 seconds it needs. This is 10 raised to minus 9 seconds. It is faster and it is not that much large, but having some size, and their storage capacity will be 8 gigabytes. This is having 2 terabytes. And they are inexpensive as compared to other registers, which are very, very expensive. Now, cache memory. Cache memory are very fast as compared to RAM, but not fast as compared to registers. And they are small. Their size is smaller as compared to RAM, but if you compare it with register, they are somewhat big. And their capacity will be 12 megabytes. And they are also expensive, very, very expensive as compared to the CPU, which is shown at the bottom. And now the first at the apex, which is very fast, whose speed is 1 nanoseconds, which are the CPU registers, and their size is very small, but their storage capacity is only 12 bytes. Only 12 bytes. 500, hundreds of bytes, you can say. 512 it is written, but only few hundreds of bytes they can store. And but their cost is very, very high, very, very expensive. So likewise, it is this hierarchy, it is very much clear about the speed, about the cost, storing capacity, their size. So you just go through this slide. So many things will get clear. One more important thing is hierarchy of data. Sometimes they ask about what are the sequence of this data. The first one, the smallest one, then likewise, what is the largest collection and what is the smallest unit. So this hierarchy of data, the first smallest unit of data is of the computer is bit. And this combination of 8 bits will give you 1 byte, which is symbolizes one character. So one character is depicted by or it is written in terms of 1 byte, 1 character, 1 byte, 8 bits. And field is a collection of various characters, and collection of related files will give you a record, and collection of related record will give you a data file, maybe in the tabular form or any other form. And all those related records, recorded data files will give you a database. So in the hierarchy and the base, it is database, then file, then record, then field, then byte, and the smallest one is bit. Like example, it is given here. This is a bit. Then the number 8 digits will give you 1 character, which is 1 byte, and collection of various bytes, it is character. Then various character will give you name, field, and then record, then file, and then database. Suppose there is a student database, it is on your screen. So in a student database, there are course file, there are their financial file, and their personal file. So all this will come under one section. It will give you a database. Now, what is a file? File is individual file, whether it is a course file or personal file or financial file. Suppose we take course file. Course file, it shows its grade, how much, which subject, what grade he or she gets. So that makes a single file. So if there are so many files, it will give database. Now file give you a particular data of a particular field, whether it is a course field or a personal or a financial. Now record means a particular, you can say particular field, like this roll number, this ID is having this course, this date, and this grade, right? So this is a record of a particular student. Then field. Field means particular column, whether it is a course one or date one or a grade one, which field. So this is a course field. All right. Byte means which byte is 8-bit character. So it is a single thing which shows the single information in the field. And then bit. Bit is a single representation of a single uh, digit. So that way it comprises of a database. The number system will go tomorrow. That's all for today. If you have any query or any question or any doubt, you can ask.
And go to the triangular pyramid. Yeah, this one.
Yes. Yes. What do you want to ask?
Nothing. I was making notes here, ma'am.
Okay, I'll send it to you in 2-3 days. This is an important one, okay? Everyone should have this slide or this triangle, this hierarchy. The smallest one is bit, then byte, then field. Combination of bytes will give you field, combination of field will give you record, and combination of various records will give you file, and all the various files will give you a database, like we have discussed in this slide. What is database? This is the student database. Course file, particular field, then a record, a particular record of a particular student, then field, particular field, which course, or date or IDs. This is there are 4 fields: ID, course, date, grade. All right, and each field, whatever it is written, it is in the form of bytes, combination of 8 bits, like that.
Ma'am.
Okay. So that's all for today.
From the exam point of view, any important questions?